Hi class, this is Mr. Morris. I'm just making a little bit of a video walking through our final exam review. The goal of this video is to show you how to work the problems. Rather than just giving you the answer key, I hope to help out by doing a series of videos where we just work through a few problems at a time, maybe a page at a time. So this is the pre-AP Chemistry Spring Final Exam. You're allowed to use this formula sheet on the test, so you can keep in mind anything you find on here, you're allowed to use on the test. You are also allowed to use a 3x5 note card front and back, so you want to utilize that. And of course, you'll be given the periodic table as always. I'll be referring to some of these things as I go throughout the video. First thing we want to do is look at page 1. This goes way back to the first semester. Very first thing we talked about in the matter unit. So match the matter type to the question. So matter types, those are elements, compounds, mixtures, homogeneous and heterogeneous. Okay, keep in mind these two, homogeneous and heterogeneous, are types of mixtures. Okay, so those are the two types of mixtures. So if it's a mixture, it's either going to be homogeneous or heterogeneous. Elements and compounds are what we call pure substances. And neither of them can be separated by physical means. Okay? Now, also keep in mind, if it's homogeneous, an element and a compound are also homogeneous. Homogeneous just means it has the same appearance all throughout it. So let's look right here. We've got copper. That's definitely a pure substance. And since we can find it on the periodic table, we know it is an element. Italian salad dressing. Well, it's got a lot of different things in it. And if you were to look at Italian salad dressing, over time it separates into different layers. You can see these different chunks throughout it. So not only do we know it's not an element or a compound, so it must be a mixture, we also know it's not homogeneous because it has a different appearance in different parts of it throughout it. So it's heterogeneous. It looks different throughout. So C and E. SiO2. I see a formula. It's more than one element, so it's not an element. It's a pure substance. That's a compound. B. And if I were to ask, it would be homogeneous. Pure substances are homogeneous. So we could put a D there. The more important thing is knowing it is a compound. Water. Well, what is water? We know that water is H2O. So if we're talking about just water, that is a compound, which is, of course, also homogeneous. All elements and compounds are homogeneous. Milk. There's some debate about whether it's homogeneous or heterogeneous. We can definitely say it's a mixture. I would go with the scientific definition and say it's heterogeneous, but because you haven't learned exactly why, I wouldn't count it wrong if you put D or E. Either one would be okay, but technically it's heterogeneous. Then we have titanium. Titanium is on the periodic table, therefore it is an element, and all elements are homogeneous. Oh, and I missed one. This element, this is homogeneous. All right, move down to the atomic structure. Atomic structure is an atom is mostly empty space. We want to say true or false. An atom is mostly empty space. That is true. It's mostly empty space, but it has a very dense center called the nucleus. Protons, neutrons, and electrons are in the nucleus. Sounds good. But electrons are not in the nucleus, so we would say it's false. Okay, so change the statement to make it true. It tells us to do that. I just crossed out electrons. So protons and neutrons are in the nucleus. The nucleus has a positive charge. True. The nucleus has protons and neutrons. It does not have electrons, therefore it's positive. electron cloud has no charge. Well, that's false. That's false. The electron cloud has, we could say it has a negative charge. Or we could say that the whole atom, if it's a neutral atom, the atom has no charge, but the electron cloud is negative. The nucleus is very dense. That is true. A lot of mass packed into a very small area, comparatively. Then we have these, the atomic structure. This is talking about isotopes. So if you need to know which notes to look at, these are the isotopes notes, or atomic structure. Trying to figure out what the symbol, atomic number, mass, charge, protons, electrons, neutrons are, or finding the name. So calcium 41. This tells me the mass number, so we'll put that down, 41. Okay. Calcium, I could find the atomic number if I knew where calcium was, so let's look on the periodic table. Calcium has an atomic number of 20. So the atomic number is 20. Ca, 20 at the bottom. And this number, the mass number, goes at the top of our symbol, 41. This is the form that you put your symbol in. Okay, if our charge is 0, if the charge is 0, that means that the protons and electrons are going to be the same number. Protons are always the same as the atomic number. So we're going to put 20, match those. And since the charge is 0, the electrons have to be the same. So put 20 again. To find the neutrons, we have to look at the mass number. Mass number is 41. The mass number is the protons plus neutrons. Protons plus neutrons equals mass number. So if I want to find out what this is, got to take away the proton. So 41 minus 20 gives me 21. And then you can check your work to make sure you did it right. 21 plus 20 gives us 41, the mass number. Okay, now right here I've got 34, the number of protons. That's where I would start. That's my atomic number, 34. I have 36 electrons. That means I have 2 more electrons than protons. And because electrons are negative, protons are positive, that means that's going to be negative. I have more negatives than positive. That makes it negative. More negative by 2. So this is a negative 2 charge. Now look at the neutrons. I have 53 neutrons, 34 protons. That gives me my mass number if I add them together. So 4 plus 3 gives me 7. And then 5 plus 3 gives me 8, 87. Come back over here and we can write out the symbol. First I got to find 34 on the periodic table. 34 is selenium. Selenium. You wouldn't get full credit for just the name. We have to put a dash and then put the mass number, 87. Se 87. And at the bottom we put 34. Scoot down, we'll go to the next one. We have Mg plus 2. 25 is the mass number and 12 is the atomic. So let's write down what we know from this. 12, that number at the bottom left, is the atomic number. Mass number, 25. If I have a plus 2 charge, put that there. Alright, I also know that this is magnesium, Mg. I could look that up on the periodic table to just check it. Is Mg indeed magnesium? Well, let's see. Mg, magnesium, yes. So check for spelling when you do that. M-A-G-N-E-S-I-U-M, magnesium, and it's magnesium 25. It's actually the magnesium 25 ion. Then I've got my protons. That's always going to be the same as atomic number. So 12. The neutrons, well, I find that by subtracting. 25 minus 12 gives me 13. And then right here, my electrons. Well, to find that, I need to look at the protons and the charge. Well, I've got to have more protons than electrons if I'm going to have a positive charge. I have to have 2 more protons than electrons. Well, I can't change the number of protons because it's got to match the atomic number, so I can just decrease the number of electrons by 2. So instead of having 12, it will have 10 electrons. Okay, now down here we're going to write electron configurations. Electron configurations. I know it says right here, but you're looking at your electron configuration notes. The selenium ion, or atom, start there, selenium atom. Se, so it has 34 electrons, and we can kind of go back just to review this. Each row is an energy level. This is the S block, this is the P block, and this is the D block. Now don't forget the D block is weird because when we get to where it says D, we're going to go down 1 energy level. So even though it's in the 4th row, we call this 3D. So let's write out our electron configuration to get us all the way down to selenium. Start here, 1s, 2, 2s, 2, 2p, and then we count how many spaces to go all the way across. 2p, 1, 2, 3, 4, 5, 6. Now we're down to the 3rd row, 3s, 2, 3p, 1, 2, 3, 5, 6, 3p, 6, 4s, 2, and then we're in D. It's not 4D, it's 3D, 10, 3D, 10. Then we go to 4P, 4, 4P, 4. So we go 1s2, 2s2, 2p6, 3s2, 3p6, just like I said just now, and 4s2, 3d10, and I believe it was 4p4. Yeah, 4p4. All right, that's the selenium atom. An atom means neutral. That means our electrons are going to be the same as the atomic number. You've got the same number of electrons you would expect. But if it says ion, that means it's not going to have the same number of electrons and protons. And this is always talking about electrons, the number of electrons. So let's look at selenium and try to decide what would be different about the ion. Well, selenium's over here. And elements that are on this side of the periodic table, on the right side of the staircase, they tend to gain more electrons. So it's going to have more electrons than what the atomic number is. It will have more than 34 electrons. And all of the elements are trying to be like the closest noble gas. So this is going to get 2 extra electrons to try to be like krypton in the number of electrons it has. So we're going to look back at what we had. The only thing we're going to change is the number of electrons in the last energy level. We're going to have 2 extra electrons. So where I have 4p4, instead of being 4, I'm going to have 2 extra, so that'll be 4p6. Let's do that. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then 4p6. Calcium. The calcium atom. So we find calcium at Ca over here. It's in the 4th row again. 4s2, 4s1, 2. So I could kind of start at the top. 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. All right, with the calcium ion, remember, That was atom. The ion is not going to have the same number of electrons as the atomic number. It's going to be like the closest noble gas. Well, this one has an atomic number of 20. All right, the two closest noble gases. One of them is 36 and the other one is 18. Which number is closer to 20? Well, 18 is just 2 away, so it's going to end up having 18 electrons. It wants to be like the closest noble gas. So calcium will lose 2 electrons to be like argon. So we're going to have 2 fewer electrons in our ion. It's going to be these 2. So it's going to end up being just that electron configuration, losing the 2 last electrons. So we have 1s2, 2s2, 2p6, 3s2, 3p6. All right, that's the first page. I'll try to post another video with the next page. I hope this was helpful.